In Db2 version 12.1.3, queries containing joins received a performance enhancement driven by the AI query optimizer. Let's take a look at a classic problematic query to understand exactly how it works. Here we break down query 84 from the TPC-DS benchmark. This query accesses data from 6 tables and includes multiple local and join predicates. Here are the local predicates, which we will color code with green. And here are the join predicates, which we will color code with yellow. With the AI query optimizer disabled, Db2 selects an access plan with the structure shown here. At the bottom of the plan, we can see the customer table is joined to the customer address table, and the optimizer estimates that the result of that join will contain about 3,200 rows. This derived result is then joined to the store returns table. On the other side of the plan, household demographics and income band are joined. Finally, the derived results from both sides are joined at the top and returned to the user. The traditional optimizer estimates this join to be 3,200 rows, but in reality, it is about 30,000 rows, causing it to select this plan with a suboptimal join order and take 18 seconds to run. This is due to the fact that the traditional optimizer only has access to limited statistical descriptions of each table. Let's see how enabling the AI optimizer can speed this query up by 4 times, by training and using neural networks to simulate the joins more accurately. When Auto AI maintenance is turned on, Db2's automatic statistic collection facility will identify which tables lack a model and quickly train one for each. Each neural network will be trained on about 1 million queries before being stored in the catalogs. When given a set of intelligently crafted predicates, the network must learn to predict the selectivity of those predicates. As the network observes more and more predicates, it learns to minimize the difference between its predicted selectivity and the true selectivity, also called the loss. The neural network loss function can be conceptualized as a mountainous surface or terrain. High points on this surface correspond to network weights that do a poor job of accurately predicting selectivity. Conversely, low points represent weights that do a good job of predicting selectivity. The state of a network during training can be thought of as a ball rolling on this surface. The objective of training is to get the ball to the lowest point in order to get the most accurate predictions. We use an algorithm called stochastic gradient descent to guide this ball to the bottom of the terrain in an average of 30 seconds per model. We're now ready to use the neural networks to improve the join cardinality estimate for this join. In order to quickly simulate the process of carrying out a join between T1 and T2, we will need to construct a filtered data distribution for each join pairing. This is done by rastering along the join axis with a hypervolume called omega in green and creating histogram bins with heights equal to the amount of data in that hypervolume as dictated by the neural network output. After the histograms are constructed, each pair of bins will be multiplied by one another in order to estimate the join axis distribution. Finally, the entire distribution is integrated over to obtain the join selectivity expressed as a percentage of the Cartesian product of the 2 tables. Coming back to our access plan, we see that we now have models available for joins at the bottom of the graph. Zooming back into our problematic join, we see that when the neural networks communicate their distributions to each other, the estimated cardinality is much closer to the actual cardinality that would result from this join, which is 30,000 rows. Once the optimizer recognizes this, it selects a more algorithmically efficient configuration of the access plan, resulting in the query taking only 5 seconds to execute from start to finish. Thus, this query executes approximately 4 times faster with the help of the AI Query Optimizer, and it required no tuning on our part other than the flick of a switch. In Db2 version 12.1.3, our optimizer is smarter than ever before, greatly reducing your need to do manual database tuning. Head over to ibm.com/db2 and try Db2 today.